computer. All right, so I'm going to try to walk you through this corresponding question out of the textbook. And this is chapter 8. What page is it in chapter 8? Page 148. But it's about corn earworms. And now I know this is about proportions because they're telling me it's about proportions. But if it was just a word problem like on a test, like, I might ask you that kind of question. And it won't be about corn earworms. What you got to do is you got to ask yourself, okay, well, what kind of variable are you measuring? Well, they're measuring, does the ear of corn have worms in it or no? So that's a yes, no situation. So I think it's a binomial distribution. I mean, there's a fixed number of trials, right? 80 years of corn. It's yes, no. The probability from corn to corn ear to corn ear stays about the same. We're guessing. I mean, that's the sample result, so we really can't use that. We could say that it's 15% since that's his claim. And what else? And they're independent, I guess. I mean, maybe the independence issue, because I mean, if you've got a stalk of corn with within one ear that's got a corn worm, chances are the next one will too, because they like to spread in clusters. So maybe, but we'll pretend he did a nice random sample all over the field and checked it out. Okay, so we'll say it's independent. But then the other condition we're going to check. So notice I'm doing this condition check. It's really important to do this because I'm going to ask you. These problems are all going to be mixed up, and you got to decide which is which, whether it's a t-test, a z-test, a proportion. So you got to kind of think about these conditions. One thing I probably won't do to you is what I'm going to show you next, but it's something you should do. So now the other condition was back in chapter 6. I think it was the discrete probability distribution when we learned about the normal approximation of the binomial distribution. And last week with confidence intervals, n times p has to be bigger than 5, and n times 1 minus p has to be bigger than 5. Well, 10% of 80 is 8, and 15% will certainly be more than that, so that satisfies that condition. And same thing here, that satisfies that condition. 85% will also be greater than 5. Now, the reason we do this is we want to see if all these sample proportions have a normal curve. If you watch that Mr., I don't remember his name, but the crazy guy with the orange hat talked about piles of p-hats. Well, if this condition is met, and we go out and get a whole bunch of samples of size 80, well, and then graph all those p-hats, all this proportion of successes, if there's a 15% chance of being right, that makes up normal distribution. So because it's a normal distribution, and when we're talking about distributions, we always want to talk about shape, center, and spread, right? So we know the shape is normal because of that normal approximation to this binomial distribution because of this. We know the center is the same as the population mean. We're hypothesizing, or Carl's hypothesizing, that 15% of the old, I guess he isn't, I guess is based on history or something like that. But this is the claim that we're trying to test. So that means that's the center. And how does that center vary? Well, it's this number. Now I did this out on let's see if I can pull up Google here. I did it out in Google Calendar, Google Calculator. Here we go, Google Calculator. And so I said 0.15 times 0.85 divided by 80, and I took the square root of the mess, and I got that number. Now, if we were doing this on paper, you could probably say 0.04 and be good enough. I caution you to do that when you're trying to make a computer happy. Rounding too much with proportions can throw them off. So I would probably use 0.03399 and go until you don't round. And that usually will work. Sometimes, if you get a calculator, just carry it in the calculator. But we'll try this. Fortunately, I don't have to make a computer happy for this problem. So I'm going to do that as the standard deviation. I know the mean is 15. Now this is a normal distribution. So I'm going to go look at David Lane applet from a couple weeks ago. And I said the mean was 15. The standard deviation was 0.0399. And the nice thing about this applet is they give us those empirical real cutoffs. So 68% of all the samples will fall between 11% and 19%, right? One standard deviation. So that's kind of like a confidence interval. I mean, it's not exact enough because because, well, it may be because this is the applet, but I would caution you not to do it this way to find the confidence interval. But anyway, so about 68% of this, all samples of size 80 will have between 11% and 19% earworms. So is his, so what do we, if we go back and look at his as the textbook here, what we're trying to do here is trying to formalize, how can I tell if this sample of 80 ears of corn that only had 6 with earworms, which gave me a 7.5%, 0.075, is that an unusual event? I mean, that's basically what we're trying to do. So let's see, let me come back to my thing here. And actually I want to come back to David Lane. That's what I want. Let's see. So is 7.5% unusual? Well, it doesn't look like it's, I mean, there's 1 standard deviation below, there's 2 standard deviations below. So up until this week, you probably would have said, because 7.5%, 0.075 is here, that's not 2 standard deviations below the mean. So you probably wouldn't call that unusual, and would use the mean and standard deviation to do this outlier test because it's a normal distribution or symmetric distribution. So what hypothesis testing does is it formalizes this a little bit. So what we're going to formalize here, we think, so we know the claim, we did the test, and the claim that is that that less than 15% of the ears have. So we're trying to say that this is far enough away. Is this far enough away from the mean or the middle to say it's unusual? So our hypothesis tests are HO. So I remember I did the condition check. I stated the claim. I didn't write it, but they gave it to us in the paper. Then I'm going to say P, because the proportion, the population proportion, is not any different. It's in the null hypothesis always says there's no difference, and so we're going to say nah. Farmer Carl's not right. He just got lucky. He just got either got a bad sample or a sample that wasn't representative of the population, or that right is 15%. And then H1 or HA, depending on what book you use and what video you watch of me, he's making the claim that no, my corn ears have less than 15% earworms. So this is the claim, and that's what we're going to test. Okay, so now this calculator will actually do this for us. So why don't I show you? I mean, I hesitate to have you use this calculator, but I know the mean, I know the middle. I would like, what I'm trying to find is what's the probability of being this below 7.5? So I'm going to go below, and I'm going to type in 7.5 here, or 0.075. I got it in proportion form, 0.075, and let it calculate it. And then what's this? So this is some Applet. So that is the p-value. That's the probability of having a z-score, or of having a sample of 7.5, a sample of 80 ears of corn only have a p-hat of 7.5% at 0.075. That's less than 5%. We think that that's less than 5%. So we could say that's unusual, but let's go formalize this a little bit. So I've got the hypotheses. I would love to have you use this applet here for doing significance tests. This doesn't do t-tests, okay? It does do proportions. It does do what sample means when you don't know the population standard deviation. And then this is what we're going to use next week in chapter 9, okay? 2 proportions. So how do you use this applet? You might have watched other videos of mine, but I'll walk you through it here. I know, let's write some stuff down. Back on the original problem, I knew that N was 80. I knew that X was 6, right? And what level of confidence are we looking at? Or what level of significance are we looking at? Come on. Here we go. We are looking at a 5% level of significance and then a 1% level of significance. So fortunately, that's just the same operation. So let's come back here to David Lane. Let's see here. And I'm going to do 2 tests. I'm going to run alpha equals 0.05, and then we run another test, alpha equals 0.01. These are the benchmarks. Remember remember how that wasn't 2 standard deviations below the mean? When you're significance testing, you can say, okay, so this is the p-value, this is the probability that I'm going to reject HO, that I think it's far enough away from the middle to say, yep, something's going on here. And if you have a lower level of significance, it's harder to pass the test. It's harder to say, I'm going to reject HO. It's harder to say that, yeah, Farmer Carl's right. His ears, that cornfield does have less than 15%. So I'm going to come here. I'm going to type in 80 for N. I'm going to do 6. I'm going to do 6 for the count. And then it gives me that point estimate, right, from confidence intervals. Of course, they told us that. So I'm going to run a test of significance. I'm going to change this to the mean of 15 because that's my claim, right? That's what I wrote. That's what I wrote right here in my HO and HA. And then it automatically sets it up for less than. You can switch this around to a right-tailed test, a two-tailed test, or a left-tailed test. That's why it's important to write H1 before you do anything. Okay, now we're going to calculate. Notice it gave me the same number, right? That's the probability of being less than 7.5, of getting a sample of 80 ears of corn with only 7.5% of them having earworms or less. And if you look 0.0301, 0.0301, see how that's the same number? So it's the same, that's the probability of having a sample that low. In hypothesis test lingo, that is the p-value, and of course he tells us that, and that's my z-score. So so what do we got going on here? So you want to do the condition check, state the claim, write your hypotheses. Here's your test statistic. Here's your p-value. Now to do this all by hand, you're going to use that formula z equals 0.075 minus 0.15 over, and then we did all that arithmetic before, so over the standard deviation of 0.0399. And you can kind of find the z-score, you'd get negative 1.88, and then you'd have to go look in the normal curve table to get a p-value, or do the critical value method. Look up that critical value, and that's on the table too. But Dr. Stevens does that. I'm not going to do that here because this is all I really need you to do. Condition check, claim, write the hypotheses, get the test statistic, get the p-value. Now we're going to make his decision. At the 5% level, is this statistically different? Is this statistically significant? Well, our p-value is smaller than 0.05. So this is the thing that says this is the cutoff. Do we get under that cutoff? Is it a small enough number? Well, it is. It's smaller. That p-value is less than 5%. So we're going to reject HO. Okay, so we're going to reject HO at the 5% level. The data supports the claim that Farmer Carl's claim that less than 15% of his corn ears or his samples or his corn would have earworms. And at the 1% level, this number is that number is bigger than the level of significance. So we fail to reject HO. Now you might see some videos, if you've been doing some looking, they might say HO is false. We don't know if it's true or false or not because this is just one sample. We don't know. We'll probably never know. We'll never know. So we say the data doesn't support that. Let me pause this video and pull up that spreadsheet for you. Dr. Stevens does this one way, and it's very similar. I just want to show you the spreadsheet, or this pause chart. This flow chart. So just to point out where I found this, so I'm in Canvas, I'm on the modules, week 10, and you see this chapter 7. So here's my video, basically where I walk you through all these applet uses, and I do it all for proportions and t-test, one sample t-test. And this is a set of notes that I have and I just open those up here if I can find them. Just a minute here. Did it open up in the other app? Yeah. So scroll all the way down, and here's a flow chart from another textbook I used to use. Here, let me clean this up a little bit so I can see this flow chart. Yeah, I highly recommend you do this, but we'll look at Dr. Stevens too, and so we can suss out the differences. There really is no difference. It's just a matter of wording. So for that, the 5% level, we reject HO. Now, my claim was, see the way I said the claim was, I know you can barely see that. Can I close this? I don't know. I can. Okay. So my claim was H1, right? So the way you use this flow chart is my original claim did not contain equality. No, I didn't say that HO was my claim. I said that H1 was my claim. So I didn't contain equality. Did I reject HO? Yes, I did. So the way you work your statement, and this is an important piece because WebAssign doesn't always make this very clear. If you're just doing the WebAssign, we're going to reject HO. That's my decision. Now we're going to make that decision in context. And the best way to do context is not to say too much. You got to cover your butt as a statistician, right? So you say the sample data supports the claim that Farmer Carl's ears of corn have less than 15% earworms, okay? Now, with the 1% level, we failed to reject HO. So same branch, and did I reject HO? No, I did not. There's not sufficient sample evidence to support the claim that Farmer Carl's corn has fewer than 15% earworms, okay? So start this as your prefix in the sentence, and then you can plug in the claim. Now, Dr. Stevens does this just a little differently. It's not much different. And maybe you like his phrasing better. Let's see, where does he do that? Up here, I think. He does the phrasing. Here you go. Here's what his phrasing says. So he says, if the alternative hypothesis supports a claim, that's what we did. That was a claim, and we reject the null hypothesis. We say the data supports the claim and that's kind of the same as the flowchart. This is where he differs a little bit. If for like this other one, when we failed to reject HO, he says there's not enough data to support the claim. I don't like that phrasing. Enough data. There's enough data. It didn't support it. Okay, so you can go with this one. He's perfectly right. That's fine. It's just that's my preference, and I either one's right. Okay, then this is if HO is the claim. This is the phrase you use. Now, if I went back to my flow chart there, how do I do if HO is the claim? Well, if HO is the claim, that means there's a condition of equality. So you do this branch, you go this branch, okay? And if you do some of those cookbook exercises, sometimes it's easier to do the HO as being the claim. Okay, so hopefully that helps you. Let's see if I answered all those questions about that problem. That should help you answer the WebAssign version. Let's see. Yeah, why was it that you could make a apparently contradictory statement? It's strictly because what you're using is the cutoff. Okay. I mean, and there's nothing. It's just arbitrary. That's why some textbooks say the confidence interval is honestly a little more informative. Let's the great thing of that Rossman Chance applet is that does a confidence interval too. Why don't I come back there just to do it since I'm talking here? Confidence interval, and what level of confidence? Well, that's the 95% level of confidence, and that's between one. See, that's less than the 15%. 15% isn't captured there, so we would say, yeah, it looks like that supports Farmer Carl's decision. If we do a 99%, that does capture 15%. So, and that's the difference between a 1% and a 5%. And I can concentrate those areas all in one end because this is a left-tailed test, right? It isn't like it's okay. So hopefully this helps. This video is probably getting too long. Give a yell if you need help.